morning, my people. We're going to do section 2 of chapter 9. It's on measuring angles and arcs. And some of this may be familiar to you, but I think a lot of this is going to be new. So pay attention, all right? Sit up, get your feet on the floor, and pay attention. Okay, so we have a circle that is not Pac Man. It is not a piece of rhubarb pie. That'd be better. But this thing here is called a central angle. Okay, so your circle's 360 degrees around. That's going to be some proportion of 360 degrees. This measure here, from there to there, that is called an arc. And depending on how you look at it, like this here, that would be called a minor arc. Oh, maybe I should do it in red, sorry. So a minor arc would be there. But if I had the same exact angle and I measured this way all the way around, that would be called a major arc. And if it happens to be exactly half the circle, like that, you call that a semicircle. So when we start talking about arcs, two arcs are congruent. This is theorem 9.1. Let's say I had an arc here and an arc here. Okay, that arc, that arc. These two arcs are going to be congruent if and only if they carve out the same number of degrees. So this is 20 degrees. This is 20 degrees. I know that these two arcs are congruent. Also, if I know those two arcs are congruent, then I know these are going to be the same number of degrees. Okay, that's theorem 9.1. Postulate 9.1 just talks about adding arcs together. So if I had that angle, and then I had this angle here, and that arc, then you can just add those two together and you'll get a giant arc. All right, I don't think any of that has been too hard. If you think about arc length though, okay? So let's talk about this for a second. So you know that this distance around the circle is the circumference, right? And the circumference is either pi times diameter or pi times twice the radius. That's the circumference of the circle. So now let's reason this out. If we have an arc, that is going to be some percentage, some proportion of the entire circle. So let's just call this arc L. So L is to the circumference as whatever this number of degrees is. So we'll call this A for the angle, is to 360 degrees. Does that make sense? So that distance is proportional to the whole distance around as that number of degrees is to the entire 360. Now, instead of circumference, I could write pi times diameter. I think the book does, for some reason, it does pi or 2 pi r. So, sorry, this is getting too messy. I'll just draw it over here. Length equals A over 360 times 2 pi r. Okay? So that's how you would figure out the length of that arc. And last thing, and this is just another way of measuring arcs. It's called radians, and it's on page 655. It says angles can also be measured in units that are based on arc length. So here's the little formula. So the radian, they're going to use this symbol, which I forgot what Greek letter that is. You should have Miss Simendaris check with her. So the radian measure is the arc length divided by the radius. So if I knew this was 5 and I knew this was, I don't know, 7, then your radian is going to be 7 divided by 5. Does that make sense? All right, so those are some vocab things for you, all based on arcs and measuring, and I think that should do for today. All right, I'll check with you again tomorrow.